Now we're going to look at powers and roots. We're going to see how to calculate them, what they are, and a few of the special examples that we need to know about. So what is a power? Well, when we multiply a number by itself a certain number of times, that is what we do. That's what a power is. So for instance, 3 to the power of 2 is when we multiply the number by itself, 3 times 3. So you can see the 3 comes up twice there. This is a little simplification of what a power is, and we'll look at it in a little bit more depth later on. You'll notice that the 2 tells us how many times it should be multiplied. In this case, because there's a 2, it's 3 times 3. Or if there was a bigger number, for instance, by here we've got 4 to the 3 is 4 times 4 times 4. It comes up 4 times. And 2 to the 5 is 2 times 2 times 2 times 2 times 2. It appears 5 times. There are special powers in the way we say them or in the answers that they give. 4 to the 2, with most powers we would say 3 to the power of 4, 6 to the power of 7, and so on. With 4 to the power of 2, we actually call it squaring. So 4 squared is 16 because 4 times 4 is 16. That 16 is what we call a square number, and it's actually a perfect square because it's a whole number multiplied by itself. So when a number is to the power of 2, we call it squaring. The number it produces is a square number, sometimes called a perfect square because it's a whole number times itself. Another one that has a special name is 4 to the power of 3. We don't say 4 to the power of 3 or 3 to the power of 3 or 7 to the power of 3. We say cubing. So 4 cubed is 4 times 4 times 4, which is 64. So a cube number is a number times itself, twice in this case, but it'll where it appears 3 times. When we have a number to the power of 1, the 1 actually becomes invisible. So 4 to the power of 1 is 4, 5 to the power of 1 is 5. So why am I even bothering to tell you about 4 to the power of 1? Well, the important thing is when we do calculations with indicia, these numbers to the certain power, sometimes our answers will be a number to the power of 1. And when that number comes up, you've got to remove the 1 to have it correctly written. So if I had the answer 6 to the power of 1, the answer would be 6. For instance, and don't worry about this actual calculation, 2 to the power of 5 divided by 2 to the power of 4 is 2 to the power of 1. But I wouldn't write down 2 to the power of 1, I would simply write down 2. Another one that will come up is a number to the power of 0. And strangely, any number to the power of 0 is 1. Now, like I said earlier, it's a little bit more complicated than just saying the number appears 3 times if it's the power of 3 or 6 times if it's the power of 6. Because what we're actually doing is we're multiplying the number of 1 by the number of times that the power shows. So 4 to the power of 2 is actually 1 times 4 times 4. We've multiplied 1 by 4 twice. 4 to the power of 4 is 1 times 4 times 4 times 4 times 4 because we've multiplied 1 by 4 times. We don't actually write this 1 times because any number times 1 is just a number, so it's kind of invisible and disappears. However, when we've got a number times to the power of 0, it's 1 times, well, not the number at all. So we just leave it at 1. Hence, All you've got to remember though is any time you have a number to the power of 0, don't write that, write 1. So what's a root? Well, a root is the opposite to squaring. So it's finding a number that, when multiplied by itself, gives the number you are calculating from. So for instance, the square root of 9 is 3, because 3 times 3 is 9. And if you notice by here, to show that we are square rooting something, or rooting something I should say, we use this root sign by here. So this by here is the square root of 4, and the answer is 2, because 2 times 2 is 4. Now we can have a root to any root, so we could have the 4th root, or the 6th root, or the 7th root. So for instance, the 4th root of 16 is 2, because 2 times 2 times 2 times 2, 4 lots of 2 there, 4 lots of times in by 2, is 16. The 5th root of 32 is 2, because 2 times 2 times 2 times 2 times 2 is 2. But you saw from the last picture I just showed, is that when we've simply got the sign and not a number, we call it the square root. When we've got the 3, then it's called the cube root. So the cube root of 64 is 4, because 4 times 4 times 4 is 64. Remember, after this point of having a cube root, the number would simply, if we're looking for the 4th root or the 5th root, we just change this to a 4 or to a 5 and so on. Calculating roots, most of the times we'll be looking and we'll be using the calculator to calculate them. The only time in which you wouldn't do that is if it's say a perfect square, and it would be one of the lower square numbers. So for instance, they might tell you what's the square root of 16, and you'd be expected to know that 4 times 4 is 16. You'd be expected to know that 16 is a square number. So that's why it's useful to learn your first 10, 12 square numbers, so that you'll instantly know what those numbers squared are, or the numbers squared that make those numbers are, and then what those numbers rooted are.